All right, guys, very good morning, very good evening. Right, so in this particular today's session, I'm going to demonstrate about a TFA, right, transparent application failover. TFA is going to be one of the brilliant feature when it comes to RAC databases, but most of the DBAs not sure, not aware of how exactly this TFA works, and then most of the RAC expert or RAC DBA, they're in the assumption that when they connect to my RAC database using scan, so automatically it's going to take care of application failover, connection failover in case of any node goes down. So that's not how exactly it's going to work. So in this particular today's session, I'm going to demonstrate with the example how that application connection will going to fail over, or the if the node goes down, how that user connected session is going to be like failed over to the other nodes using my lab setup here. So I have a two node rack, node one and then node two here. This is my lab setup. So I'm going to demonstrate the TFA concept here. So just give a brief idea on that. So this is node one and node two, right? So I can just mention it as a node one, and then this is my node two. So where you can see your databases are, under common shared storage. So this is a typical RAC architecture. So if I can say my DB, or like I can say dev DB1 instance one, and then my dev DB instance two is connected here. Two instances are running on two nodes here, and then for this, I have my database which is residing under shared storage here. So this is my actual dev DB. So dev DB which is on my shared storage, where both the rack instances are connected to that shared storage, where my data files, control files, my read logs and archive logs are resides here. So if any end user application, like for example, one user connected to node one and other user connected to node two via scan, right? So we have something called scan here. So scan, and then the end users are connect here. The moment he connect, the scan intelligently route the connection to any one of the node, and the other user comes, and then the connection goes to second node, and again another user comes, connection go to node one, again another user comes, connection goes to node two. Like your scan is going to distribute that transactions. So like for example, if I say this is my, I can simply say this is my C1 connection, and then which is going and connected to node 1, and then this is my client 2 C2 connection which is coming under going to node 2, and then this is my client 3 connection which is coming and going to node 1, and then my C4 client connection coming and going under node 2. So in case of, you know if this particular node 1 goes down, crashed, or your entire database instance goes down, or the ASM goes down, or server itself goes down, what happens to this connection C1 client and then this connection C3 client? So currently C1 and C3 connected here, and then C2 and then C4 connected here. So as a DBA, RAC DBA, like they easily can answer that these two connections are failed over to this particular node here. So your C1 and then C3 will fail over to your existing node. That's called, application failover. So we say that, whenever end users connected via scan, it's going to fail over to any of the surviving node. That's not how it's going to work. So in order to achieve this failover, you need to configure something called TFA. Sorry, sorry for that. TAF. That's a transparent application failover, TAF. So TFA is different. Trace file analyzer, that's a different story. But what we're talking about is a TAF, transparent application failover. So how we can achieve this one? If the node goes down, automatically the connection has to pass to the other surviving node. How we're going to do that one? That's what I'm going to demonstrate using service methods. So let's jump on to my lab here. I have node 1 and node 2. Let's take one of the database for the illustration. I can take this policy database here. Right, so srvctl status database -d, and then your database name here. So your instance 1, instance 2 running on node 1 and node 2, right? And then if I do srctl, srvctl config database -d and then your database name. So that's your database details. You're going to get it out here, right? RAC12C, your home, your SP file, password file, and instance 1, instance 2 running on node 1 and node 2. The same command, if you do it on node 2, the result is going to be same. RAC12C instance 2 here, and then you're going to run the same command, srvctl status database. You can see same two instance running on instance 1 running on node 1, instance 2 running on node 2. Again, same configuration, srctl config database. It's going to give the same result on the node 2 as well. Since it's a cluster database, you can run it on any one of the node. You don't need to run on both the nodes, right? The TAF, right? Transparent application failover. It has 4 steps here, right? So create a service, and then start a service, and then connect your end user using that service name, and then your TFA is configured using these 4 steps here. Step number 1, create a service. Step number 2, start a service. And step number 3, create your TNS entry for that end user connection, and then connect to the database using that service name. That's it. So your configuration is done. TFA configuration is done. So let's illustrate in the first place. So if I do on the node 1 TNS ping, if I ping TNS ping on node 1, so TNS ping RAC12C, I'm going to use the database name, which is going to connect using a scan here, right? This is my scan. All right, so that's one thing. If I try to connect sys username at that scan name, it's going to connect to any one of the node. So I'll just take 2 more sessions. So for this demonstration purpose, I'm going to connect 2 more servers. Server 1, server 2. This is some extra servers. For just for connection purpose, I'm using it. I'm going to make this as a red color so that you can differentiate. Right, so this is, I'm going to make it as a red color here. These are like extra connections for testing purpose. I'm using it here. Root. And then you can easily get to know with the IP address or the node names are different here. I'll make this as a red color. So I'll use this only for connection purpose. So I can just connect. I can set the environment here for some dummy database. RAC standby 1. Okay. What I can do now here, the first test, right? So I'm just going to use SQL plus sys password @ your scan name, right? As I said, the moment the end user connect to scan, the connection will go either node 1 or node 2, right? So I'm just going to try to connect using scan, right? Let's go here. If I try to connect sys user password scan name, and then connection will go to either node 1 or node 2, right? So in simple words, probably I can write here. So for the ease of understanding, so I have my node 1, my node 2. So I have my instance 1 here. I have my instance 2 here, and then this is my scan. So my scan is here. The scan name is RAC12C, right? Like, sorry, where is my scan name? This is my scan name. So this is my scan name here. I'll just type that scan name here. A scan name means it is gonna, this is a DB name which is gonna resolve through scan RAC12C, right? So the connection 1, I'm trying to connect. This is connection 1. Sys password @ TNS name. That's a scan name. It will result through scan and then SSDB. So this first connection, either it go to node 1 or node 2. You can pretty much very validate using select instance name from VDAL instance. That will tell you which instance it connected. So it says it connected to RAC second instance, right? So your first connection went to second node, right? And then I have one more session here. Let's connect one more instance over there. RAC and by 2. So I'll just Good, and then where is this one? Right. So now I'm gonna do the same thing. I'll just use the same connection SQL plus sysACTBA from this other session here. And then this time we'll see which instance it has connected. I'm going to run the same command. Right, you can see it connected to node 1 here. So if I can take one more session, like it'll be your scan will be keep on distributing the connection to node 2, node 1, node 2, node 1. Like, these are like end user application connections. Your scan is intelligent enough to distribute that all the incoming connection to node 1 and node 2 and node 1 and node 2, right? So that's how it works. Uh, Now we know like the scan is distributing the connection to node 2 and then node 1. It's all working fine. So now uh, I'm going to do instance 1 and what happens to my connections. Right now I have this session which is connected to instance 2. I have this session which is connected to instance 1. Let's uh, you know stop your instance 1. I'm going to stop my database instance 1. Like the moment I stop the instance 1, the connection, the connected session on the node 1 will be like disconnected. Doesn't matter whether it's a DML status, DML statement or select statement or whatever it is. The moment I stop my instance 1, your the connection will be gone. The whichever session connected to node 1, it's all gone. Like I'll go here. I'm just gonna SSD stop instance name and then your database name. The moment I stop my instance, your session is gone here. This one. Let it go on. Like I'll take a duplicate tab here. I can tail that alert log. Locate alert underscore rack 12C1. So this is my alert log. Tail hyphen F. Alright, so stopping background process, instance shutdown completed. If you see, like instance is shut down here. Now if I run srvctl status, my database name, so your instance 1 is down. So rack 12C is not running on node 1. So instance 1 is down. The moment instance 1 is down, your connected session here, whatever this connected session gone. If I try to run the same query, right? So session end of communication gone, this session is gone. So then what's the point of scan? Even though the end users or applications are connected via scan, but ideally if this node goes down, automatically it has to fail over to the other node, right? That's not possible here. Even though if I connect with the scan, I'm not connecting with the instance name, right? I'm connecting with the scan TNS details, but the connection, it did not fail over. So that's a bad thing, right? So even though if I connect with the scan name, doesn't matter, it will not fail over. Like your connection sessions are terminated here. Like nobody can do anything, right? How I can avoid this one? And then if I try to exit and then try to reconnect, now your instance 1 is gone forever. Whatever that incoming connection now, all connection will go to your node 2 only. If I try to connect here now, new session, it will go to default your instance 2 because that's the only instance is available as of now. Right? It's connected. If I run the same command here, and then default your connection will go to instance 2, right? Because that's the only available instance now. If you're having 4 node, then again scan is distribute the connection to other servers, other nodes, right? So now how I can make this failover possible, right? If the connections whatever available here, the moment node goes down, or connection whatever available here, if this node goes down, automatically that connection should go to other nodes. How I can do that one? That's where your TAF, transparent application failover, comes into picture. So how I'm going to make that one right now here? Here are the steps. What I'll do now? This is one thing, right? Like the moment you stop, your session gone. That is just an idle session. They're not doing any select, not doing any insert, or not doing any update, nothing. Still that session is terminated here the moment instance goes down, right? And then even if you try to do any insert operations, like I'm trying to do like 1 million record insert here. Out of that, like 0.5 million record inserted, and then node goes down, and then gone case. So your whatever the transactions will be rolled back. So let's do it one more time. Like I can uh, start my instance here, whatever I shut it down. I'm just going to start that instance. Right. So I started here. So now what I'll do, other session here, whatever connected to instance 2 here, uh, I can do some transactions here, like begin, for, insert values, and then I'm going to insert some for loop with Malik. I'll just going to connect with the sys, and then I'm going to trying to do insert some 1 million record, and later I try to do commit this one. But in between, your instance goes down, gone case again. Your session will terminate in the middle. All whatever the insert has done, like 0.5 million or zero 0.6 or 0.7 million, all the record it has to roll back, right? So my instance started here. Let's check the status. Right. So both are running on both the nodes. Now I'll try to connect one more time here. It should go to again node 1 or node 2, but doesn't matter. Yeah, now it went to again in node 1. So now we'll try to do some insert statement here, right? So you can see I'm going to do 1 million record insert here. View does not exist here. Probably it will be in Malik user. Let's connect with Malik user. Malik, probably Malik username is password Malik. Oh, it should not be SSDBA. Let's connect to the right. It's connected here. Malik user with Malik password connected here. Let's try with this 1 million record insert, and then right. So it's going on. Like 1 million insert record is going to take a lot of time. And then meantime, I'm going to shut down my instance 1 again. Stop instance 1. And then assuming that this transaction is an insert statement, out of this 1 million, 0.5 million insert is done. And then that time your instance went down here. Your node 1 went down. So whatever that 0.5 million insert has done, it has to roll back everything. Like, again, the session has to disconnect. So what I mean to prove here, like it doesn't matter whether it's idle session, select query, insert query, update query, delete query. If the instance goes down or node goes down, the transactions will be killed. Everything will be rolled back, right? So you can see here, whatever this insert statement, immediate shutdown, close in progress, and then gone. So whatever the transactions are gone, right? So your instance is down now here, right? So that's a other test case why I wanted to prove it here, right? So now how I can make this possible. Like if I try to connect now and then uh, try to check for that result, so it will be like nothing. Let's connect back here. I'll just go on second node. I'll just connect, and then I can query for that student table, and then it will be like 0, no record inside that, right? So 0 records, because even though these transactions might have done some insert, the moment that node goes down or instance goes down, all the transactions will be rolled back. So the how I can achieve that and the failover here uh, by using TAF, transparent application failover. That's what I'm gonna configure now here, TAF. So again, as I said, 4 step. First, create a service. So I'm going to create the service. service add service and your database name and your service name. I'm going to use like RAC 12C underscore service. And then your instances, preferred instances, instance 1 and instance 2, -p, basic method, and then -e, what kind of a failover is supported here. In RAC, we support 2 kinds of a failures. One is a session failure and other one is a query failure. Either you can do a -e, select or session. You can mention whatever you want. You can either mention select or you can mention session. So if like 10 users are connected here and then those users are doing some insert, update, delete, and then if you make a failover you are adding the service, essentially add service to this database, service name, and then your instances and method is basic. And then if you do session failure, all these 10 users session will fail over here. They have to resubmit that query. If out of these 10 users, one is doing insert, one is doing select, one is doing update, one is doing some delete, and whatever the transaction they do, these 10 users, only that session will fail over to node 2. Those all 10 users, they have to resubmit their queries again. That is a failure type called session failure. There's the one more failure type called session select failure. Select failure means, again, assuming that out of these 10 users, like some are doing insert, two users are doing insert, two users are doing select, and two users are doing update, and four users are doing delete. If I do this failure method as a select, only the select queries are failed over. Like, all these 10 transactions will fail over here, no doubt in that. But this, out of this 10 sessions, these two sessions, right, the select queries, assuming that one guy is doing a 10 million record select statement, one guy is doing like 100 million select statement, and then out of this 10 million, 55 million records are fetched in the node 1, and then out of this 100 million, like 10 million records are fetched already in this node 1. The moment node goes down here, all these 10 transactions will be like failed over to node 2, and then this insert you session, they have to resubmit that query, update and delete, again they have to resubmit that query, and then these two select queries, right, they no need to resubmit. Whatever this 5 million they already fetched, it will start it from the 5 million onwards. Whatever the result is fetched, it's gonna start from there. That is your select query, select type of failure. These are the only supported failure options in RAC. Whenever that instance goes down, all the user connections will be failed over to other nodes. That is called a session failure, and other one is called select failure. Only select queries will fail over, and then it will continue from the point where it has failed over. And other insert, update, delete, they have to resubmit, refire the queries, right? Only select queries are supported in RAC. If they're doing insert, update, and delete, only that session will fail over, but they have to resubmit that uh, query again. So let's configure this service here. I'm just gonna configure what here. I'm gonna go back here. I'm gonna start that instance now. Start that instance one. Now I'm gonna, once the instance is started, I'm gonna start. I'm gonna add my service. I'm gonna start my service, and I'm going to check the service status. Now I'm going to connect using that service name, whatever the service name I'm going to create here. I'm going to connect using that service name here, right? So once I connect with the service name, the failover will be possible, right? Now instance is started here, right? So instance 1 and 2 both are running. So now I can add the service here. Let's copy this one, add that service. Service is added, and then start your service. You can see this is my service name, RAC Tulsi service. Service is started. Check your service status, which is running on instance 1 and instance 2, both are running. The service is running. So now I'm going to do SQL plus Malik, and then password, and then with the service name. If I try to do TNS ping of the service name, if I do here TNS ping, and then the service name. Okay, not resolving here. Let's Oracle node 1. It might not be available here. Let's connect here on node 1 itself. TNS ping, not there. Let's go ahead and check our TNS file. CD dollar Oracle home CD network. We need to add uh, the second step, right? First step is create service, start your service, and then now add the service name into your TNS file via TNS file. So I'm just going to add my service name. So this is my RAC policy, and then instead of service name RAC policy, I'm going to use my service name here. So I'll just take a copy of that. I'm just going to add a entry over here, and then here, this is my service name. I'm going to use this service name. add it over here. Okay, not coming here. Let me add the service name here. In the service name. Right, so we added our service name here, and then I can change the name of this one to service name, actual C SRV service. So now you can try to ping your service name. It should ping now, right? So you're able to ping that service name, right? So now I'm gonna connect using that service name, SQL plus Malik and password, and then the service name. Let's connect here now, right? Connected, and then the check the instance, which instance you connected. Now it connected to instance one. Well and good, right? So once you connected there, now what we can do, you can shut down your instance too, and you can do SRCTL shutdown or connect to instance and shut it down. And then your session right now it is showing here, right? Malik user using the service name, which is connected to instance one. The moment you shut down your instance, automatically your session will connect to your instance two, because you are using service name here. The service name will automatically fail over, right? That's your TAF, transparent application failure. So now I'm going to connect to instance one, and I'm just going to do shut immediate, or like you can do SRVCTL stop instance, doesn't matter. Like your instance one shutting down, and then see the magic here. Like where is that one here? Right now it is connected to instance one, and if I run that, say, select query, your instance automatically get changed to your instance two, right? You can see instance two. So that's the magic of TF, transparent application failover. If this user is doing some select query, as I said, out is doing a 10 million records. Out of that, already 5 million record is fetched in instance one. Automatically, it failed over to instance two. You're gonna start it from that 5 million onwards. That's the select query failover. That's the service what we defined here. The type of failover is select, and there's a type of failure called session failure. That also you can do it, right? So that's the beauty of your failure, right? You can run this query, select name, failure method, failure type, and other things. So you can just run inside your database here. Yeah, again, set pages, lines 1000, run that query again. So again, like we don't need all of this. Select name, comma, failure method, comma, failure type, and then from DB, like I can check for the DB service from DB underscore services. So you can see service name, failure method is basics, that's a default, and the failure type is select. So that's what we defined while creating our service here, right? With that, right? So SRCTL add service, your database name, service name, and the preferred instances. Type is basic service, and then the type of the failure method is select failure. That's what we're seeing it here. It's a select failure, right? So it's a type of select failure. So when you select queries, automatically it'll fail over, and then you'll want to start it from the scratch. If there's a any insert going on, and then his session is gonna fail over to next uh, instance. For example, assuming that uh, this particular guy who has connected to instance one, he's doing some insert statement here, and then he's doing a 10 million insert record. Out of that 5 million insert record he has done, and then the session has failed over to instance two, and then his kind of only session has failed over to instance two, and then all the 5 million record whatever insert done, it has to roll back. It will roll back internally everything, and then he has to refire that query, whatever that insert query, whatever like insert, update, delete, he has to resubmit that queries again. Only that select queries failover is supported, and then other than that, any query like insert, update, delete, the end users or the application team, they have to resubmit that query, right? So that's a simple understanding of you know TAF, transparent application failover, how it's going to work. So again, once again, these are only 4 steps here. Create a service. You can define what type of failover you want. Select query failover or session failover. Select query default has a session failover. That's the highest precedence. And then You can start the service. You can add the TNS entry with the service name, whatever the service name you're going to define. After that, you can ask that end user to connect via service name. Right. So that's a simple understanding of how transparent application failover works. That's it for today's session, guys. We'll connect again with a new session in our upcoming demos. Thank you.